All right, so we're looking at 6.3, which is differential equations, separation of variables, which we've kind of already introduced the previous day. So your objectives are to recognize and solve differential equations that can be solved by separation of variables. You can't with everything. And use differential equations to model and to solve applied problems. Okay, so the first thing we're going to take a look at is separation of variables. It says consider a differential equation that can be written in this form: m of x plus n of y times dy dx equals 0, where m is a continuous function of x alone and n is a continuous function of y alone. Basically, our idea is to separate the variables with all of the x's on one side and all of the y's on another. Okay. Not every single differential equation is separable, and so that's one thing that we need to recognize. When can you, when can't you? Okay, so let's take a look. For these below, for number 1, right, I have x squared plus 3y dy dx equals 0. All right, so I think it makes sense to move that x squared over first, and then go ahead and multiply both sides by dx. So I get 3y dy equals negative x squared dx. This has been separable then, and I would be able to solve it using the separation process. Note, I'm not actually asking you to do it. I'm just getting you to practice the separation aspect. Okay. For number 2 then, what we are doing is sine of x, and I'm going to write this as dy dx instead of y prime equals cosine x. Okay, and so I think it makes sense you have to move the dx over to the other side. So one thing to notice, right, is that this could be a first good move. You are going to have to move the dx or the sine x as well. So this would be dy equals cosine x divided by sine x dx. Okay, and so that would be the separated version. And again, all of the y stuff is on one side, all of the x stuff is on the other. One thing to quickly note, you certainly could write this, or if you wanted to, cosine x divided by sine x is cotangent x, and so you could also write that as well. For number 3, I have x times dy over dx, and I'd strongly recommend going ahead and writing that for yourself so you don't get confused. Okay. So the first thing you're going to do is multiply both sides by that denominator. So you're going to have x times dy over dx equals 2 times the quantity e to the y plus 1. Okay. And then what I would say is, again, that dx is kind of going to be your decider. You have to multiply both sides by dx to separate the x's and y's, and that means all of my y's need to be over here, all my x's need to be over there. So I'm basically going to flip-flop these. So I'm going to divide both sides by those, okay, making it 1 over e to the y plus 1 dy equals 2 over x dx, okay? And I would suggest doing that overall. I think the easier you can make the y side, the better. Technically, the 2 could also come over if you want, but there is no reason for that to do so. It can be on either side as long as you can take that antiderivative in the next step. So I think this is slightly different than it is on the filled-in notes, but this would also be a perfectly acceptable solution. Okay. All right, so we know that we have to be able to separate them in order to be able to solve, so let's actually take a look at example 1. Okay, I will say separation of variables and solving with that is a very classic and often seen FRQ problem, so you need to feel comfortable doing these for AP test. Okay, all right, so our first job when I see this is to go through the separation. Okay, and you can do this as many steps as you need to, as long as you are doing it in a way that you are doing mathematically legal things. All right, so I know all the y stuff has to go here, all the x stuff is going to have to be on this side, and so it looks like I'm going to have 1 over y dy equals x over x squared plus 4 dx, and that should take care of it. And now I'm going to go ahead and take the integral of both sides, okay? The left-hand side, not a big deal. But on the right-hand side, it's going to take a little bit of work, right? And I need to say it. So, is this a integral that I know? No. Could I use substitution? Okay, and I'm going to try a couple of different things. One thing I'm going to try is to make the whole bottom the u. And I think if you do that, it makes sense that what's going to happen is you are going to get the cancellation you want. I'm going to do it off to the side and then just bring the answer back. Okay, so I'm going to have the integral of x over u du over 2x. My x's cancel, so it's the same thing as 1/2 integral of 1 over u du, or 1/2 natural log absolute value of u plus c. Remember, when I bring it back, I need to take it back to x's, so this is going to be 1/2 natural log absolute value of x squared plus 4 plus c. Okay, one thing to note, this quantity is always going to be positive, so I don't really need the absolute value sign. Okay, and I might start looking at ways that I could kind of combine it as much as possible. And so one thing that I know that I could do is write this as natural log absolute value of y equals, and taking this back as an exponent inside the natural log. So the natural log of the square root of x squared plus 4 plus c. And I think the easier you can make this, the better off you will be, okay? All right, if I'm interested in getting y alone, I know that I can do e to the on both sides, okay? So e to the natural log of y would just be y. On this side, e to the natural log square root of x squared plus 4 plus c. Remember, that's the same thing as e to the natural log square root of x squared plus 4 times e to the c. And typically we are going to call that a just to avoid confusion. So my generic or general solution would be y equals a. And then once you have that, e and the natural log cancel each other out. So a times the square root of x squared plus 4. This would be my general solution. Okay, you would not be able to do this cancellation if you hadn't taken that exponent or that leading coefficient in as an exponent. So it's important to be flexible with your writing so that you can get those cancellations.